Hello students, this is P.Aileen Sonia, Assistant Professor in RMD Engineering College. From the subject Basic Electrical, Electronics and Measurement Engineering, from Unit 5 which deals about electrical measurement, I will be taking about Lvdt, LDR and Piezoelectric Transducer. Lvdt which comes under Inductive Transducer. Inductive transducer operates on the principle of variation of self-inductance of a coil and variation of mutual inductance. It is expressed as N phi by I, where N is the number of turns, phi is magnetic flux and I is current. Substituting the expressions for magnetic flux, phi, magnetic flux density B and magnetic field intensity H, L is given as mu n square A by L. Therefore, the inductance of a coil can be varied by changing the permeability of the core material or by changing the position of the core inside the coil, changing the number of turns through which current will flow in the coil and changing the ratio of A by L of the coil. So here, by changing the position of the core inside the coil, we will be seeing how Lvdt will be transforming the linear displacement into electrical voltage. Lvdt, linear variable differential transformer. It is also known as linear variable differential transducer. It converts linear movement into electrical signal for linear position measurement. Construction. The transformer consists of primary winding P and two secondary windings S1 and S2 wound on the cylindrical former. So in this diagram we can see that AC source is given to the primary winding. The secondary winding is placed on either side of the primary winding. Inside this former we have a movable core. So based on the displacement of this movable core, the flux will be induced on the secondary side and thereby we will be getting the output voltage. The secondary winding will be connected in such a way that the opposite voltage, in such a way that the output voltage will be the difference of voltage in secondary winding and voltage in secondary winding 2, that is E0 equal to E1 minus E2. The iron core will be of high permeability to reduce harmonics and high sensitivity. The Lvdt is placed inside stainless steel housing because it will provide electrostatic and electromagnetic shielding. Principle of operation. It is similar to transformer principle, as we know that in transformer, when input supply is given to the primary winding, the flux from the primary winding travels through the core to the secondary winding. And if the circuit is closed in the secondary winding, current will be flowing in the secondary winding. So here also based on the position of the core, the output voltage will be produced in the secondary winding. Core at null position. So when the core is at the median of S1 and S2, the flux induced from the primary to the secondary will be the same. So since the flux in S1 and S2 is the same, the output voltage, which is the difference between ES1 and ES2, will be 0. Core at left position. If the core has moved to the left position, flux from the primary to the secondary winding 1 will be more than S2. That is, S1 flux will be more than S2 flux. Therefore, the output voltage ES1 will be greater than output voltage ES2. Therefore, the output voltage is in phase with the primary voltage. Core at right position. If the core has moved to the right, the flux induced in the secondary winding 2 will be greater than the flux induced in the secondary winding 1. Since the flux induced in secondary winding 2 is greater, the output voltage, that is the voltage in the secondary winding 2, will be greater than the voltage in the secondary winding 1. Therefore, the output voltage ES2 will be of greater value. Therefore, the two differential voltages are 180 degree out of phase with each other. By comparing the magnitude and phase of the output voltage with that of the source, the amount and direction of the movement of the core and hence of displacement may be determined. The amount of output voltage may be measured to determine the displacement. The output signal may also be applied to a recorder or to a controller that can restore the moving system to its normal position. This figure shows the variation of output voltage against displacement for various positions of core. When the displacement is 0, that is core at null position, we see that output voltage. When the core has moved to left, we see it is indicated by phi equal to 60 degree. And the core at right, that is output voltage is out of phase by 180 degree, no? So that is our core at right position. The curve is practically linear for small displacements up to 5 mm. Beyond this range of displacement, the curve starts to deviate from the straight line. LDR, light dependent resistor. Other names are photoelectric transducer, photoresistor or photocell or photoconductor. LDR is a photoresistor or LDR or a photoresistor is a device whose resistivity is a function of the incident electromagnetic radiation. Hence, they are light sensitive devices. They are also called as photoconductors, photoconductive cells or simply photocell. So, LDR is made up of semiconductor material having high resistance. So, this is the symbol of LDR. Semiconductor device which is of high resistance. So, here this arrow mark indicates the light falling on this LDR. Principle. So, it works on the principle of photoconductivity. Photoconductivity is an optical phenomenon in which the material's conductivity is increased when light is absorbed by the material. When light falls, that is, when the photons fall on the device, the electron in the valence band of the semiconductor material are excited to the conduction band. These photons in the incident light should have energy greater than the band gap of the semiconductor material to make the electrons jump from the valence band to the conduction band. Hence, when light having enough energy strikes on the device, more and more electrons are excited to the conduction band, which results in large number of charge carriers. The result of this process is more and more current will start to flow through the device when the circuit is closed. And hence, it is said that the resistance of the device has been decreased. Types of LDR. Based on the materials used, they are classified as intrinsic photoresistors and extrinsic photoresistors. So, intrinsic means it will be made up of pure semiconductor materials like silicon or germanium. Extrinsic, as you know, it will be doped with impurities called as dopants. So, these dopants will create new energy bands above the valence band which are filled with electrons. So, it reduces the band gap and less energy is required in exciting them. Construction. The structure of LDR consists of a light sensitive material which is deposited on an insulating substrate such as ceramic. So, on the ceramic, the LDR material will be placed. The material will be in zigzag pattern in order to obtain the desired resistance and power rating. The metal film contact is on the sides. The resistance of these contacts, that is the metal film contact, should be less. as possible to make sure that the resistance mainly changes due to the effect of light only. The materials used for this LDR will be cadmium sulfide, cadmium selenide, indium antimonide. So the use of lead and cadmium is avoided as they are harmful to the environment. So this is a practical LDR. So this is a metal film contact we are seeing at the sides. So on the ceramic substrate, the LDR material is placed. So applications, these are the various applications. They are mostly used as light sensors. Piezoelectric transducer. Piezoelectric transducer is a device that uses the piezoelectric effect to measure changes in acceleration, pressure, strain, temperature or force by converting this energy into an electrical energy. So here in this transducer, either acceleration, pressure, strain, or temperature or force will be converted to electrical form. So the voltage produced by the piezoelectric transducer is measured by voltage measuring instruments. So in this way, we can measure physical quantities like mechanical stress or force. So it consists of a quartz crystal which is made up of silicon and oxygen arranged in crystalline structure. So the mechanical stress or force, so there are two ways of stress here, compressive stress or tensile stress. In the case of compressive stress, positive charges are induced in one side and negative charges are induced in the opposite side. The crystal size gets thinner and longer due to compressive stress. In the case of tensile stress, charges are induced in reverse as compared to compressive stress, and quartz crystal gets shorter and fatter. So as we see that it is based on the principle of piezoelectric effect. So what is piezoelectric effect? When a mechanical stress or force are applied on quartz crystal, it will produce electrical charge on the quartz crystal surface. So another unique characteristic of piezoelectric effect is it is reversible. That is, when voltage is applied to them, they tend to change dimensions along certain planes. So already we are seeing here under electric transducer that if you are giving any force, stress, it is converted to electrical form. So reversible means what? Again, from the electrical form, it can be converted to the physical quantity, like for stress or force. That is a crystal dimension will get changed when we are applying electrical field. And also it is a self-generating transducer. So self-generating transducer is what? It does not require electric voltage source for operation. The electric voltage produced by piezoelectric transducer varies to applied stress or force depending upon how much we are giving applying stress or force. It will be varying. So the right side we see here, this is a practical piezoelectric transducer. So here we see here the crystal is placed here. The crystal is placed between the solid base and the force summing member. An externally applied force entering the transducer through its pressure port applies pressure to the top of the crystal. This produces an EMF across the crystal proportional to the magnitude of applied pressure. So here crystal is placed in about base and here the pressure port is here. So when the externally applied pressure is applied on this pressure port, because of this force summing member, the pressure will be applied on the crystal. Thereby the output, the voltage generated from the crystal will be generated on the surface of the crystal. So the materials used for piezoelectric transducer are Rochelle salt, ammonium dihydrogen phosphate quartz, ceramics made with barium titanate, dipotassium tartrate, potassium dihydrogen phosphate, and lithium sulfate. The magnitude and polarity of the induced surface charges are proportional to the magnitude and direction of applied force. So the charge is given by F into D. The F is applied force in Newton and D is the crystal charge sensitivity in coulombs per Newton. The force F causes a change in thickness of the crystal by del T. So when we are applying stress, there will be a change in the shape of the crystal. So that is given by del T. So F is given as A E by T into del T. So E is nothing but the Young's modulus of elasticity in Newton per meter square, and A is area of crystal and T is thickness of the crystal. The output voltage because of the electrode charges is given by E naught equal to Q by C. Already we have seen Q is F into D and C capacitance is given by epsilon naught epsilon R into A divided by T. So here T denotes the thickness of crystal. Substituting these expressions in equation 3, we get as E naught equal to F into D into T divided by A into epsilon naught epsilon R. So we know that force by area is pressure. So instead of F by A, we substitute P. So we get it as D by epsilon naught epsilon R into T into P. So D by epsilon naught epsilon R is given as voltage sensitivity of the crystal. So instead of D by epsilon naught epsilon R, we are substituting as G. So E naught of output voltage is given by GTP. So it also can be rewritten as G equal to E naught divided by TP or P naught by T divided by P. So modes of operation of piezoelectric crystals are thickness shear, phase shear, thickness expansion and transverse expansion. These are the various ways you can apply stress and thereby the crystal shape changes. Equivalent circuit of the piezoelectric transducer is shown in the figure. So the source is a charge generator. The value of the charge is Q equal to F into D. The charge generated is across the capacitance Cp of the crystal and its leak resistance is given as Rp. The charge generator can be replaced by an equivalent voltage source having a voltage of P naught equal to Q divided by Cp. So Q already we have seen it is F into D, so it is given as Fd divided by Cp. That's what we had already seen in the previous expressions. So applications. So these are the variety of applications of piezoelectric materials. So it is used in microphones, it is used in electric lighter, it is used in restaurants or airports for door opening. Thank you.